MathCounts people. This is prime factorization and factors. This is to cover our factoring stretch from our 2024-2025 new book problems. Some of the stuff we're going to have to go into deeper later, especially when we talk about factoring polynomials. But here we go. This should help you out with this stretch here. So let's talk about prime factorization. So prime factorization is where you the word factor means multiple, right? So it's where you find all the prime numbers that multiply to give you a certain number. So for instance, we've got the prime factorization of 720. So we want to find all of the prime numbers that will give us 720. So I'm going to start breaking down 720 until I get down to prime numbers. So 720, I might break it down as like 72 times 10. And 10 is 2 times 5. And 72 is 9 times 8, and 9 is 3 times 3, and 8 is 4 times 2, and 4 is 2 times 2. I now have all my prime factors at the end of my factor tree here. I might have to zoom in here. Let's zoom in a little bit there. There you go. All right, so looking at my prime factors, I've got 1, 2, 3, 4 2s. So that is 2 to the 4th power. I've got 1, 2, 3s here. So that's 3 to the 2nd power. And then I've got a prime number of 5 over here. So that would be 5 to the 1st power. All right, so I've got 2 to the 4th, 3 to the 2nd, 5 to the 1st. There we go. Okay, so here we've got all of our prime factors. We've got 1, 2, 3, 4, 5, 3, 3 right there. So we got 4 2s, 2 3s, and 1 5. I forgot to add this to the list, but one of the things that we can do with prime factorization is if you want to find the number of divisors. So if you want to find the number of numbers that go into 720 evenly, you can use this prime factorization. So with the 2 to the 4th power, when you think of all the different ways that you can use the 2s, you can not use a 2. You can use, that'd be 2 to the 0 power. You could use a 2 to the 1st power, a 2 to the 2nd power, a 2 to the 3rd power, or a 2 to the 4th power when you're trying to find a divisor. So that's 1, 2, 3, 4, 5 different ways that you could use 2s. For the 3s, I could use 3 to the 0 power, or I could use 3 to the 1st power, or 3 to the 2nd power. So there are 3 ways that I could use the 3s. I could use them as a 1, as a 3, or as a 9 when I'm looking for my divisors. So there's 3 ways I could use that one. For the 5s, I could use the 5s as just a 1, so 5 to the 0 power, or I could do 5 to the 1st power. So that would be 2 ways that I can use the 5s. So if I'm looking for the number of divisors for the number 720, there's 5 ways I could use the 2s, there's 3 ways I could use the 3s, and there's 2 ways that I could use the 5s. And so that comes out to a total of 15 times 2, 30 different divisors. You could, of course, come up with a list of all your divisors, but this is the quickest way to find your divisors. Basically, you take your exponents and add 1. So exponent of 4 plus 1, there's 5. 2 plus 1, because we're thinking that we cannot use the 3 as well. So there's 3 ways we can do that. And 1 plus 1, 2. I can either use a 5 or not use a 5. So that comes out to 30 divisors. So that's a really quick way that we can use prime factorization to find the number of divisors or the number of numbers that go into 720. All right, moving on. LCM, least common multiple. That is the smallest number that 2 numbers will go into evenly. And then we've got GCD, the greatest common divisor. That's the biggest number that will go into 2 different numbers. Now, both of these can be found using prime factorization much easier. So we already said that 720 was 2 to the fourth, 3 to the second, and 5 to the first. Okay, 84, let's break that down really fast. 84 would be 2 times 42. 42 is 6 times 7. 6 is 2 times 3. So the prime factorization of 84, I'm writing really small this morning. I don't know why. Here, I'll zoom in. I know this is way too small. Sorry. I made a half sheet, and then for some reason, I just automatically started writing tiny on the half sheet. So this is 2 to the second times 3 to the first times 7 to the first. Okay, so I've broken down those two factors. If I want to find the least common multiple, the LCM, well, I know that the smallest number possible for my least common multiple would be the 720, right? Because I want to find out what's the smallest number that both of these numbers will go into evenly. So if I start with 720, my least common multiple will have 2 to the fourth, 3 to the second, and 5 to the first. Because my biggest number has to go into the least common multiple. So there I go. Now I look at and see if this number, if 84 can go into this number. Well, 84 has 2 to the second power. It has 2 2s. Well, there's 4 2s right here, so that will go in. 84 has 3 to the first power. This one has 2 3s, so 3 will go into that. And then 84 has 7. Well, there's no 7s in this. Therefore, my LCM needs a 7. Now, both of these numbers will go into it. 2 to the fourth is covered here. 3 to the second is covered here. 5 to the first is covered here. For this one, 2 to the second is covered with 2 to the fourth. 3 to the first is covered with 3 to the second. And then I had to add 7. So basically, all I have to do to find a number, the smallest number, that 720 and 84 will go into evenly, is take 720, this is 720, and then multiply by 7. So 720 times 7, I'm just going to use a calculator because my brain's not working this morning. I get 5,040. So the LCM is 5,040. All right, so that's the LCM. The GCD, the greatest common factor, is all of the factors that they have in common. They both have 2s. What's the most 2s they both have? Well, this one has 4 2s, and this one has 2 2s. So the most 2s that they both have is 2 of them, 2 to the second. This one has 3s, and this one has 3s. So what's the most 3s they both have? This one has 2 3s, this one has 1 3. So 1 3 would be the most 3s they both have. This one has a 5, but this one doesn't. So 5 can't be part of my greatest common divisor. This one has a 7, but this one doesn't. So 7 can't be part of my greatest common divisor. Therefore, my greatest common divisor would be 2 to the second, 4, times 3 to the 3. So 4 times 3, the greatest common divisor is 12. So for this one, we take our biggest number and then ask ourselves, are all of the numbers in the smaller number included? For the other one, we look for the number of prime factors they both have. They both had 2 2s and 1 3. So that would be 12. All right. On to factoring polynomials. Now this goes pretty deep. This is not enough just to cover it in 4 examples here, but we're going to just kind of look at it a little bit and see what we can do with it. Okay, so factoring a polynomial is a process of taking a polynomial like this and turning it into a multiplication problem. Okay? Now, one of the things that if you multiply binomials together, that's like two polynomials that have 2 terms or whatever. What you'll notice is there's a pattern, and the pattern to it is that this last number, you'll get two numbers that multiply to give you this number, and then those same two numbers add to give you this number. So we're looking for what multiplies to give me 36 and what adds to give me negative 20. So I'm looking for two numbers. They multiply and give me positive 36, but add to give me negative 20. Now, if they're multiplying and giving me a positive and adding and giving a negative, that means both of the numbers have to be negative. Okay, so of the numbers that give me 36, which ones are going to add up to give me 20? Well, I would start with 1. 1 and 36, no, that's not 20. Then I'd start with 2. 2 and 18, does that give me 20? Yes, I found my numbers, 2 and 18. All right, so these two numbers that we've just found here, they become part of my factors. We would do our factors. X squared is x times x. That's how we're getting x squared. The x is multiplying by the x. The number that goes in the back is negative 2 and negative 18. Negative 2 times negative 18 is positive 36. Where are we getting the negative 20 from? Negative 2 times x, that's negative 2x. And x times negative 18. So negative 2x, negative 18x, add those together, that's where you're getting the negative 20x from. Okay, let's try it one more time. So for this one, we've got negative 6, and then the coefficient of the x to the first term is, negative 1. So what multiplies to give me a negative 6, but adds to give me a negative 1? Well, I know if I'm multiplying and getting a negative that one of my two numbers is going to be negative. And since this number is negative, my bigger number is negative. That means my smaller number is positive. All right, so I start with 1. 1 and 6, no, that makes negative 5. Let's try 2. 2 and negative 3. Yes, that works. 2 times negative 3 is negative 6. 2 minus 3 is negative 1. So this turns into x plus 2, x minus 3. We call these the factors. Oh, that's minus 3. Why did I write 2? I don't know. And we can see where these numbers are coming from. X times x, x squared. 2 times negative 3, negative 6. Where does that middle number come from? From 2 times x, which is 2x, and x times negative 3, which is negative 3x. So I've got 2x minus 3x, and that comes out to negative x in the middle there. All right, we can actually use these factors to find what we call the roots. The roots are the solutions to equations. Notice these weren't equations, they were expressions. So now we can use these roots that we're finding, or these factors that we're finding, to find the roots or the solutions to these equations. Since I have x to the second power, that is indicating to me that there are going to be two solutions to this equation. So I'm going to start by factoring it. I need something that multiplies to give me an 84, but adds to give me 5. Okay, so I need a smaller number that's negative and a bigger number that's positive. That's the only way to multiply and give me negative 84, but add to give me 5. So I'd start with 1. 1 and 84, that's not it. 2. 2 and you can like make a table of numbers here. So 1 and 84. Nope, that doesn't work. 2 and 42, that doesn't work. Does 3 go into 84? Yes, because 8 plus 4 is 12, so 3 has to go in there. So 3 goes in there 28 times. Does 4 go in there? Yes. 4 goes in there 21 times. Does 5 go in there? No. Does 6 go in there? Yep, 6 goes in there. 6 goes in there once, so 24, so 14 times. We're getting closer to our number because right now we've got -6 and +14. So we're at 8. We're really close. Let's try the next one. Does 7 go in there? Yes, 7 goes in there 12 times, and we found our number. -7, +12, that equals 5. Awesome. So this becomes x minus 7 times x plus 12. Now these two things are multiplied together and they equal 0. That means one of those has to be 0 because 0 times a number is 0 or a number times 0 is 0. This is called the principle of zero products. Because if you're multiplying two things and they equal 0, one of these two things has to be 0. So x minus 7 could be 0, which means x could be 7. X plus 12 could be 0, which means x could be -12. Those are the roots of the equation or the solutions. So the roots of this quadratic, because it's got an x squared, we call them quadratics, the roots are 7 and -12. So we factor it, and we can set our factors equal to 0 to solve it. Now these problems get a little bit sticky when you've got a coefficient, a leading coefficient in front over here. So what you have to realize is, this is called the guess and check method. So 3x squared, there's only really one way to do that. That could be 3x and x, right, to get the 3x squared. The -10, there's a couple ways that you could do the -10. You could do 1 and 10 or 2 and 5. So we want -13, but since there's a leading coefficient, you can't just do the diamond to find this out. So what we're going to do is just plug in the numbers and see if it's going to work in some way. Now I do know that one of these is positive, one of them's negative, and the bigger number will be negative because I got -13 here. So let's say that I put -10 over here. 3 times -10, I'll do it like here so you can actually see it. Let's say I do 1 and -10. 3 times -10 is -30, and then x times 1 is 1x. -30x and 1x is -29x. That's not my number. I can't do it the other way. If I did 10 and 1, that would be 3 times 1, which is 3, and 10 times 1, which is 10, but one of them has to be negative, so that's not going to work. So let's try 2 and 5, and this is the one that's going to work. If I try 2 here and -5 here, 2 times -5 is -10, and then we see these two multiply to give me 2x, these two multiply to give me -15x. -15x and 2x is -13x. So there I go. I've got my two factors. And now to find our roots or our solution, all I have to do is set these equal to 0. 3x plus 2 equals 0. Subtract 2, we get 3x is equal to -2. Divide by 3. One of our answers is -2/3. My other answer, my other root, we would do x minus 5 equals 0, add 5, and x is 5. So my two answers are 5 and -2/3. Like I said, this is a really deep subject, factoring. There's a lot of different things that you can do with it. I think next week we'll go a little bit deeper into this and practice this a little bit more. All right, so that's all I got for you this week. Have fun with your factoring stretch, and I will see you next time. Bye-bye.